A waterspout is an intense columnar vortex that occurs over a body of water. They are connected to a towering cumuliform cloud or a cumulonimbus cloud. In the common form, it is a non-supercell tornado over water. While it is often weaker than most of its land counterparts, stronger versions spawned by mesocyclones do occur. Waterspouts do not suck up water. They are small and weak rotating columns of air over water. While waterspouts form mostly in the tropics and subtropical areas, other areas also report waterspouts, including Europe, New Zealand, the Great Lakes and Antarctica. Although rare, waterspouts have been observed in connection with lake-effect snow precipitation bands. Waterspouts have a 5-part life cycle: formation of a dark spot on the water surface, spiral pattern on the water surface, formation of a spray ring, development of the visible condensation funnel, and ultimately decay. Formation: waterspouts exist on a microscale, where their environment is less than 2 km in width. The cloud from which they develop can be as innocuous as a moderate cumulus, or as great as a supercell. While some waterspouts are strong and tornadic in nature, most are much weaker and caused by different atmospheric dynamics. They normally develop in moisture-laden environments as their parent clouds are in the process of development, and it is theorized they spin as they move up the surface boundary from the horizontal shear near the surface, and then stretch upwards to the cloud once the low-level shear vortex aligns with a developing cumulus cloud or thunderstorm. Weak tornadoes, known as landspouts, have been shown to develop in a similar manner. More than one waterspout can occur in the same vicinity at the same time. As many as 9 simultaneous waterspouts have been reported on Lake Michigan. Types: non-tornadic. Waterspouts that are not associated with a rotating updraft of a supercell thunderstorm are known as non-tornadic, or fair-weather waterspouts, and are by far the most common type. Fair-weather waterspouts occur in coastal waters and are associated with dark, flat-bottomed, developing convective cumulus towers. Waterspouts of this type rapidly develop and dissipate, having life cycles shorter than 20 minutes. They usually rate no higher than EFO on the enhanced Fujita scale, generally exhibiting winds of less than 30 ams. They are most frequently seen in tropical and subtropical climates, with upwards of 400 per year observed in the Florida Keys. They typically move slowly, if at all, since the cloud they are attached to is horizontally static, being formed by vertical convective action instead of the subduction-adduction interaction between colliding fronts. Fair-weather waterspouts are very similar in both appearance and mechanics to landspouts, and largely behave as such if they move ashore. Tornadic waterspouts, also accurately referred to as tornadoes over water, are formed from mesocyclonic action in a manner essentially identical to traditional land-based tornadoes in connection with severe thunderstorms, but simply occurring over water. A tornado which travels from land to a body of water would also be considered a tornadic waterspout. Since the vast majority of mesocyclonic thunderstorms occur in landlocked areas of the United States, true tornadic waterspouts are correspondingly rarer than their fair-weather counterparts in that country. However, in some areas, such as the Adriatic, Aegean and Ionian Seas, tornadic waterspouts can make up half of the total number. Snowspout. A winter waterspout, also known as a snow devil, an icespout, an ice devil, a snownado, or a snowspout, is an extremely rare instance of a waterspout forming under the base of a snow squall. The term winter waterspout is used to differentiate between the common warm season waterspout and this rare winter season event. Very little is known about this phenomenon and only 6 known pictures of this event exist to date, 4 of which were taken in Ontario, Canada. There are a couple of critical criteria for the formation of a winter waterspout. Very cold temperatures need to be present over a body of water warm enough to produce fog resembling steam above the water's surface. Like the more efficient lake effect snow events, winds focusing down the axis of long lakes enhance wind convergence and likely enhance their development. Climatology. Though the majority occur in the tropics, they can seasonally appear in temperate areas throughout the world, and are common across the western coast of Europe as well as the British Isles and several areas of the Mediterranean and Baltic Sea. They are not restricted to salt water. Many have been reported on lakes and rivers including the Great Lakes and the St. Lawrence River. Waterspouts are fairly common on the Great Lakes during late summer and early fall, with a record 66+ waterspouts reported over just a 7-day period in 2003. They are more frequent within 100 kilometers from the coast than further out at sea. Waterspouts are common along the southeast U.S. coast, especially off southern Florida and the Keys, and can happen over seas, bays, and lakes worldwide. Approximately 160 waterspouts are currently reported per year across Europe, with the Netherlands reporting the most at 60, followed by Spain and Italy at 25, and the United Kingdom at 15. They are most common in late summer. In the Northern Hemisphere, September has been pinpointed as the prime month of formation. Waterspouts are frequently observed off the east coast of Australia, with several being described by Joseph Banks during the voyage of the Endeavour in 1770. Life cycle: there are 5 stages to the waterspout life cycle. Initially, a prominent circular, light-colored disk appears on the surface of the water, surrounded by a larger dark area of indeterminate shape. After the formation of these colored disks on the water, a pattern of light and dark-colored spiral bands develop from the dark spot on the water surface. Then, a dense annulus of sea spray, called a cascade, appears around the dark spot with what appears to be an eye. Eventually, the waterspout becomes a visible funnel from the water surface to the overhead cloud. The spray vortex can rise to a height of several hundred feet or more and often creates a visible wake and an associated wave train as it moves. Eventually, the funnel and spray vortex begin to dissipate as the inflow of warm air into the vortex weakens, ending the waterspout's life cycle. Nautical threat: waterspouts have long been recognized as serious marine hazards. Stronger waterspouts can be dangerous, posing threats to watercraft, aircraft and swimmers. It is recommended to keep a considerable distance from these phenomena, and to always be on alert through weather reports. The United States National Weather Service will often issue special marine warnings when waterspouts are likely or have been sighted over coastal waters, or tornado warnings when waterspouts are expected to move onshore. Research and forecasting: Zilog Waterspout Index. The Zilog Waterspout Index, developed by Canadian meteorologist Wade Zilog, is used to predict conditions favorable for waterspout development. The SWI ranges from a 10 to +10, where values greater than or equal to 0 represent conditions favorable for waterspout development. International Center for Waterspout Research, the ICWR, is a non-governmental organization of individuals from around the world who are interested in the field of waterspouts from a research, operational and safety perspective. Originally a forum for researchers and meteorologists, the ICWR has expanded interest and contribution from storm chasers, the media, the marine and aviation communities, and from private individuals. See also: funnel cloud, landspout, tornado, tornadogenesis. References. External links: General, a series of pictures from the boat Nicorette getting impressively close to the NSW South Coast tornadic waterspout. A USA Today online article on waterspouts, http://www.usatoday.com. Spouts HTM, online waterspout article, pictures of cold core waterspouts over Lake Michigan on September 30, 2006. Archived from the original on March 10, 2007. Large waterspout off southern Tonga Tip, February 2014, http: AOS Research Engine umich.edu. waterspoutvideo.com. The most comprehensive website with waterspout footage from the Florida Keys. Updated often. Experimental Great Lakes Forecast, Winter Waterspout, a Winter Waterspout Monthly Weather Review, February 1907. http: www.electricityuniverse.com. Index PHP. Level equals picture and it equals 216.